Hello, my name is Joshua, and today I'll be presenting my QUAS individual report. So I'll be going through my two tasks. So task 1 will be test of goodness of fit, and task 2 will be test of independence. So going through task 1 first, I had to randomly sample 400 samples out of 10,000 records. And to do that, I first created a column for the RNG. And in the data analysis panel from the data option in the ribbon, I selected the random number generation option. And from there, the settings were the number of variables be 1 because there's only one column. Number of random numbers be 10,000 because there's only 10,000 rows. Distribution be uniform. Random C is 5,077 according to my admin number. And the output range is as here. So after that, I sorted the entire data set by ascending order of the random numbers, so the RNG column. And once done, it looks something like this. So all numbers are within 0 and 1, and the first 400 rows were selected as required. So after that, I divided the weight into 11 equal parts to create a frequency table. To do that, I first created descriptive analysis for the weight column with a confidence of 95%, as I required the difference between the max and min to generate the size of each bin. So I had to subtract them and after that divide them by 11, just to find the size of each bin, which happens to be 13.84. Right? After doing that, I created the frequencies by use of a function. So the COUNTIF function, so the weight column more than equal to the bin lower bound, and the weight column less than equal to bin upper bound. This references the weight column and checks if each one of these values are within the lower and upper bound of each bin. So from there on, I actually performed the chi-square goodness of fit test on the data with a significance level of 5%. And from here, the number of bins are of course 11. And the observed frequency is the frequency of each bin that we covered earlier on. The probability due to the normal distribution assumption is actually the normal distribution of the upper value minus the normal distribution of the lower value. So from there on, the expected frequency is just probability times total of observed frequencies. And the chi-square itself is, of course, a measure of difference between the observed and expected frequencies. And so it's calculated with observed frequency minus expected frequency squared over expected frequency. Alright, and we move on to the conclusion for task 1. My conclusion is for null hypothesis, null hypothesis is that the weight follows a normal distribution for the null hypothesis. And for the out hypothesis, weight does not follow a normal distribution. Degrees of freedom in this case would be number of groups minus 1, 11 groups, 11 minus 1, so it's 10. Alpha as given to us, 0.05. So the test statistics in this case are 13.68, and the critical values, which is chi-square inverse, 0.95 to 10 degrees of freedom, is 18.31. And hence, the chi-square stats is actually less than the critical value, so we must conclude that weight does follow a normal distribution at A alpha equals to 0.05. Moving on to task 2. So task 2, exact same as task 1, the starting, which will be randomly sampling data again. So again, created a RNG column, same process, went to random number generation. And from there, I actually moved on roughly the same way as well. So number of variables 1 because there's only one column. Number of random numbers 735 this time around because there are only 735 rows. Distribution is uniform. And the random C is again 5077, output range as seen here. So from here again, I sorted the RNG column in ascending, so smallest to largest, and then selected the first 619 rows as required. So from there, I move on to actually create the contingency table of gender and drunk driving. So the contingency table is created through the pivot table found under the table option in the insert tab. And pivot tables do the same thing as contingency tables. So no other settings required, they only needed to put in the row number. So that's the number of row for the driver, gender, and drunk columns. So in this case, 619. Right, and at the end of it, pivot table looks something like this. It was edited to have gender as the rows, drunk as the columns, and driver as the counts. So at the end result, it just looks something like this. So moving onwards to the chi-square test of independence. The observed frequency values are from the pivot table and just show the frequencies by category, i.e. male, yes is 85. Right? The expected frequency values are calculated via the formula, which is just column total times row total divided by grand total. right? And the chi-square values, again, they are a measure of difference between the observed and expected frequencies, and again are calculated as observed frequency minus expected frequency squared over expected frequency. In this case, 3.66. Alright, so we move on to the conclusion. The null and out hypothesis are that gender and drunk driving are independent of each other for the null hypothesis, and the gender and drunk driving are not independent of each other for the out hypothesis. For degrees of freedom, this one is slightly different. It will be number of rows minus 1 times number of columns minus 1. As we have 2 of each, so it will be 2 minus 1 times 2 minus 1, which is equivalent to 1. Right, and the alpha, which is given to us, 0.05. And over here, we have already given the test statistics, which is 3.66, and the critical value, which is chi-square inverse, 0.95 to 1 degree of freedom, which is 3.84. Hence, again, test statistics is actually less than critical value. The evidence is insufficient to reject the null hypothesis at alpha equals to 0.05. Thus, I conclude that gender and drunk driving are independent of each other at alpha equals to 0.05. That actually brings me to the end of my presentation. Thank you very much for listening.